Hello, physics students. I've made this video mainly for the people that aren't here when we talk about the velocity versus time graph. Now, I'm not going to tell you how to do all of the velocity time graphs, but I want to give you some hints in this video. And hopefully it clarifies it up. Once you get your answers for the velocity time graphs, I want to check them and ask you some questions just to be able to make sure that we got them. So let's look over here. I drew a couple position time graphs. Or position versus clock reading graphs. And so what we've defined thus far, position is a space given at a given time interval where you're at. It's kind of like a mile marker on a road. And clock reading is whatever it reads. Whatever your watch reads, it is. Velocity, however, is, by definition, the slope of a position versus time graph. So when I look down here, it's velocity versus clock reading, or velocity versus time. I'm going to have to use this position time graph to come up with my velocity time graph. I could also use my motion map to help me in this process as well. The key thing is this. I look at this line right here and describe the slope. Well, it's a flat line, which means it doesn't have a slope. It means that y is equal to some value, and it's constant. And so if I think about what that means, the position stays the same throughout. Well, that means you're just standing still. And so what's that mean about your velocity, which is basically speed, but with a direction component? That means you don't have any velocity. So therefore, your velocity graph should be right here on 0. So I don't want to cross the black and red too much because it mixes the markers, but it should be right here on that 0, and I can write 0 right here to indicate that it's right at 0. My other graph here is not a flat line, so it's going to take a little bit more thinking. So now, the position time graph, the velocity is the slope of a position time graph. So this is typically what people say. Well, they notice that that's positive, and so they know, well, you're going to have a positive velocity. But here's the two things that people often guess. They either guess this, or let me get my blue marker and guess this. People that draw the red line typically would say something like, well, it's moving in the positive position, it's changing its position, therefore this guy is also going to be changing its velocity. The people that have the blue line would say, well, I get a single value from the slope. Because I get a single value from the slope, I should get a single value as the velocity. And the reason it's on the positive sign, I can still specify that that's 0. The reason it's on the positive is because I have a positive slope. So the correct answer is actually the blue line because, just as I said, the slope of a line gives you a single number. The fact that it is a straight line means that it's moving at constant velocity. And so if it's moving at constant velocity, then you should see it at some given number, like 2 or 1. It's just always staying the same. So this is an introduction to velocity time. Now, some of the other ones, especially on lab P.2.2, the motion detector lab, it gets a little bit more complicated. One thing I will say before I end this video is on some of the graphs, let me draw it over here. They have like a position time graph like that, and they ask you to draw the velocity time. They have little dots there. Those dots are very important because that tells us at that given clock reading, something's happening different on the velocity time and position time. So make sure you pay very close attention to those. All right, good luck.